Vitamin K in foods is absorbed from the middle and last part of the small intestine. As with other fat-soluble vitamins, absorption depends on the presence of bile and pancreatic juices, and it's enhanced by dietary fat. While the liver is the main storage site, vitamin K is also found in other tissues, for example bone and heart. Compared to other fat-soluble vitamins, the total body pool of vitamin K is small and turnover of vitamin K is rapid. The body recycles vitamin K in a process called the vitamin K cycle, allowing the vitamin to be reused many times. Vitamin K is essential for the formation of biologically active forms of a range of proteins. These proteins are called vitamin K-dependent proteins. Vitamin K participates in the conversion of glutamate residues of these proteins to gamma-carboxyl glutamate residues by addition of a carboxyl group. This process is called carboxylation. Once vitamin K has converted the glutamate, the protein is then able to bind calcium. There are more than a dozen proteins affected by vitamin K. These proteins are vital for blood coagulation and bone strength. Blood must flow freely and not clot unless there is a break in a blood vessel. Clotting is normally triggered by a ravage in a blood vessel, such as a cut artery. The liver produces several proteins important in blood clotting, including prothrombin and fibrinogen. These two proteins circulate in blood. One of the first steps in blood clotting is triggered by the formation of thrombin from prothrombin. Thrombin then accelerates the conversion of fibrinogen to fibrin, which consists of fine threads that tangle together to form a blood clot. Vitamin K is necessary for the liver to synthesize prothrombin. Vitamin K converts the glutamate that is in prothrombin, enabling it to bind calcium. Without adequate vitamin K, prothrombin production slows, leading to a bleeding tendency. There are several other proteins involved in blood clotting that are activated by vitamin K. Balance and control are important parts of blood clotting. So in addition to speeding blood clotting, vitamin K also assists in creating proteins that slow down this process. Bones are formed by bone-forming cells called osteoblasts. The osteoblast cells synthesize osteocalcin under the direction of the active form of vitamin D, calcitriol. Vitamin K is needed to enable osteocalcin to bind minerals to bones. Vitamin K is used as a coenzyme to convert 3 glutamate residues in osteocalcin that enables bone mineralization. Higher vitamin K levels may be protective against osteoporosis and age-related fracture. Several studies have found a correlation between higher vitamin K levels and lowered risk of hip fracture. However, since leafy green vegetables are the primary source of vitamin K, this protective effect could be from other nutrients, such as the calcium or magnesium present in vegetables.